Hi, my name is Allison, and this video is brought to you by the Math and Science Learning Center as part of the Quantitative Methods lecture series. In this video, I will show you how to solve linear programming problems in Excel. So let's jump right into our example. As we read through this scenario, I want you to look for three things that we're going to identify in this problem. So when we're setting up a linear programming model, the first thing we need to do is identify our decision variables. Our decision variables are our final answer, what we're looking for in the end, the thing that we have control over in production. Okay, the second thing that we are going to find is our objective function. So when we have a linear programming scenario, our goal is to either maximize or minimize something. So a lot of times we'll maximize profit or revenue and maybe try to minimize cost, right? One of those two scenarios. So we're going to identify whether we're maximizing or minimizing, and also a function that represents the thing that we are trying to maximize or minimize. The third thing that we need to identify are our constraints. These are the conditions under which we are producing something. So anything that limits our production, such as time or other resources, those are our constraints, things that keep us from infinitely producing. Okay, so in this scenario, we have a farmer who is planning to plant acres of corn and green beans on her 12-acre land. She has to plant at least 6 acres worth of crops, and she has $1,500 to spend. Each acre of corn costs $200 to plant, and each acre of green beans costs $100 to plant. We also know that the farmer only has 12 hours to get her crops planted, and each acre of corn takes 1 hour to plant, and each acre of green beans takes 2 hours to plant. In terms of profits, she can earn $450 per acre of corn and $350 per acre of green beans. So we want to know how many acres of each she should plant in order to maximize profits. Okay, so our first goal is to figure out our decision variables. So that, again, that's what we're going to be producing in the end. Our final answer will be based on these variables. So our goal is to find how many acres of each, right? And each being of corn and green beans. So I'm going to go ahead and write out my decision variables here. And I'm also going to put them down here. So now these two cells represent our variables. So I'm just going to put beside here so we are aware that this is like my X variable and this is like my Y, essentially. What I'm now doing is making B20 like my X variable. So every time I reference that cell, I'm referencing X. And every time I reference B21, I'm referencing Y. The same thing with these columns. This is now going to represent like my X column, and this is going to represent my Y column. So our second thing that we need to do is identify our objective function. So we are told that our goal is to maximize profits. So our goal is to maximize. That means that I need to know how much profit I'm making off of each thing. So I'm told that I'm making $450 per acre of corn and $350 per acre of green beans. And let's just put that information in our chart so we can keep track of everything. I'm making $450 off of corn, $350 off of beans. In this cell, I'm going to put my objective function. So I'm going to put an equals. And now these are my objective coefficients. So for each acre of corn, I'm going to make $450. So I want to multiply that by every acre of corn I'm going to be planting in the end. Okay, and I want to add that to however much I'm going to make off the beans. So I'm going to multiply 350 by the number of acre of beans I'm going to be planting. Now you can see right now it's a dash, and that's because we don't have any values for our corn and our beans right now, but by the end we will have some value there that tells us how many acres of corn to plant and how many acres of beans to plant. And then they will be input into this formula and give us the final maximum profit that our farmer could potentially earn. And so lastly, we need to identify our constraints. So again, the constraints are the conditions under which we are producing something. Okay, so the first thing I notice is that she's planting it on her 12 acres of land. That means that she has a restriction in how many acres she has. So that's one thing that's going to limit her production, is that she only has 12 acres available. So when she adds up the amount of corn acres that she's planting and the amount of bean acres that she's planting, they need to be less than or equal to 12. Okay, so I can say that the coefficient on these is 1 and 1, right? Because I'm doing an x plus y is less than or equal to 12. I'm actually going to put that formula in the usage section. So I'm going to hit enter, and I'm going to reference my coefficient times my variable cell, which we agreed was B20. I'm actually going to set that in stone because I'm going to keep referencing it as I go through these formulas, and that will allow me to copy it down to other cells. So if you put some dollar signs in there, it sets it in stone so that I keep referencing B20. So that gives me the corn usage, and then I want to do the same for beans. So I take my coefficient and I multiply it by the variable, which again I'm going to set in stone because I'm going to keep referencing B21 every time I'm talking about beans. Okay, so that is going to be my constraint formula, right, which is less than or equal to 12. So now we also know that she has to plant at least 6 acres worth of crops. So that's another constraint, is that she has an acreage minimum. Okay? Meaning that when she adds up her amount of corn and green bean acreage, it needs to be greater than or equal to 6. Now, because I put these dollar signs in the previous formula, I get to just drag this down because it's going to stay the same. Notice that all that changed was that I'm now referencing these coefficients rather than the ones above them. But I still get to multiply them by my decision variables, which are represented by B20 and B21. Next, we're told that she has $1,500 to spend on seeds, equipment, and labor. So that's another constraint for us, is that she has a budget, right? Only so much money that she can spend. So everything, when she adds it up, needs to be less than or equal to $1,500. Now here's where it changes from our previous scenario, though. We are told that each acre of corn costs $200 to plant, and each acre of green beans costs $100 to plant. So I need to reflect that in my coefficients column. So the amount that's spent on corn for each acre is 200, and the amount that's spent on green beans is 100. But the usage column is going to stay the same, right? Because I'm still just referencing those coefficients and multiplying them by our decision variables. So I can just drag that down, and that's my formula. All right, we're given one last constraint, and that's that she only has 12 hours to get her crops planted. So we know that time is going to be one of the conditions that keeps her from producing infinite amounts of crops. Okay? We know that however much she plants, it only needs to take her at most 12 hours. Okay? And we're told that an acre of corn takes 1 hour to plant, and an acre of green beans takes 2 hours to plant. So again, I can just drag that right down my usage column. Okay, so the only other thing that we need to fill in here is our slack and surplus column. All this tells me is that in the end, when my usage column gets filled in, it's going to tell me how much extra resources I have, or how many extra resources I have. So for instance, it's possible that we won't use all of her acres, and this will tell me how much extra she has. Or maybe she won't plant exactly 6 acres. This will tell me how many acres above 6 she planted. So I'm going to take my available column and subtract away the usage. Right? So right now it says 12 because our usage column has not been filled in by Solver. But I can just drag that right down. Generally with the greater than or equal to sign, we would flip it because that's a surplus situation. But you'll be able to see in the end that all that changes is the negative sign. So now that we've filled in all of our formulas, we can now use Solver to actually get to our final solution and understand how many acres of corn and how many acres of green beans our farmer should plant. So I'm going to go to Data, and I'm going to click over here to Solver. Now, you might not already have that in your Excel. You can always just go to the Add-ins feature and put it into your Excel software. So to set objective, this is where we're going to put our profit function in this case, right? If you had a minimizing cost situation, you would put in your cost cell, right? And we have designated that as B22. So that's the thing that we're trying to maximize or minimize. In this case, we are maximizing profit, so I would hit that button if it wasn't already filled in. Our changing variable cells are where we've put our decision variables, our X and Y, so I'm going to reference B20 and B21 in that place. Okay, then I need to input my constraints. So I'm going to hit Add. In cell reference, I'm going to put my usage column. And in constraint, I'm going to put my available. Okay. Now in this case, because the signs in the middle are going different ways, I can't just drag it all the way down. So I'm going to put them individually. So I'm going to grab my usage cell, make sure the sign is correct in the middle, and then grab my available and hit Add. Okay. Then I can do the same thing, just all the way down the column, making sure that my sign in the middle is correct. I'm just going to grab these together since they are the same sign. Great. So now you can see we have our constraints all input into our solver. So you're almost done. The only thing that you need to do to finish it out is to make sure that this box is checked. So this makes sure that we don't get any negative answers in the end. And then we also need to make sure that this says simplex LP. You'll see that there's other options here, but we want to go with the linear programming method. And so we can hit solve. If you want, you can grab a sensitivity report. This gives you more information that will be covered in a different video. So you can just click that and get a sensitivity report if you so choose. Great. So you can see that all of our usage column and our decision variables and our profit, anywhere that we put formulas, was filled in. So we find that we're using 9 acres, we're using all of our budget and all of our time to plant 6 acres of corn and 3 acres of green beans to get a maximum profit of $3,750. So that's the basics of setting up a linear programming problem in Excel. If you still have any questions on this, please feel free to visit the Math and Science Learning Center, and a tutor should be able to help you there.